Hey man, you ever looking to flatter?
Here's the thing about refraction, folks. Yeah, light does bend. It bends up, it bends down, all depending on uh, the atmosphere, weather conditions, I should say, because, well, we're not on a sphere. There may be a sphere appearance above us due to our perspective, but there's no sphere or curve that we can find. But the reason I'm putting out this video is because it was a very interesting video. Now, if you notice where I'm filming from, I'm not quite in my spot that I normally film from. Now, I went there 3 days in a row. Um, and really what I'd like to do is do a comparison of these 3 days. The other 2 days I was able to get in my spot, but I was about 30 to 40 feet um, I guess you would have to say east of my normal spot. Um, but it was pretty good too because I did have a good shot to the north across the sidewalk and all. But what's interesting about this is number one, you've seen how far away that boat actually was. But, it does appear to be floating above the what we call the apparent horizon, but this boat is actually on the water. You can actually see its wake. Water's just blending in, but if you look closely, which here shortly, I'm gonna darken up the screen a little bit. I'm gonna use a little contrast and a little take down the brightness a little bit, and I'm gonna do that right about now. Okay, I took the contrast up to 5 and the brightness down to minus 50. Um, and right here is what's pretty interesting too is you see this band of light above the water or above the apparent horizon. That's actually the light bending upward. And although the light bends upward, it does not take objects and bend them upward. In other words, what we're seeing on the water is on the water. Um, but when I compare these to a lot of my other observations, and believe me, I have thousands of these. Some days there's a mirroring that's caused, and this mirroring, I've seen boats vanish, a mile and a half out, 2 miles. And then on other days where I have a nice crisp visibility, boats vanish, 9, 10 miles out. And this is impossible, even if you use their refraction index um, and their Earth curve calculator. It just does not match. And I don't care if you talk about standards, you know, all these different atmospheric conditions. Nothing's going to bend the objects back up to the surface. If anything, um, this light refraction, this bending of the light upwards is what blocks out boats, blocks out objects, or distorts them beyond recognition. That's number one. As you see that sign, or let's look at this sign just to the right of the sign itself. That is Billy Steele's rack. And if you look at it, it's more erect, it's more straight up and down, it's skinnier, it's not blown out of proportion or what I would call magnified. It is approximately the size that it should be. Um, and that's what's interesting about this footage because When we talk about light, I always talk about angle of light. And what I noticed is sometimes, you know, depending on which direction I'm looking, north, south, um, west, or west. I'm not normally looking east because east behind me is land. But this is something too that I'm going to take a screenshot of. All right, I took a screenshot right there because I want to compare it to the footage that I got after the sun departure. Um, Also, again, here you can see the wake of the boat. So that's the Bayport entrance rack right there. And you can notice because of the sign to the right of it that I am off to the left of where I normally sit because that sign is usually almost touching or appearing to touch the bird rack itself. But that sign is at least 100 yards away from that um, bird rack. Now you notice me using my manual exposure to turn the light up and down, and that's why I wanted to cut the light because I was actually adding too much light to it, um, which was kind of um, illuminating and hiding, any objects. The more light gets put on an object, of course, you eventually can't see the object. Now, I may have had darkened this up, but you'll see I'm using the compensation exposure or the manual exposure to add more or less light to it. Now, where you start seeing this little sliver just below the land there, that's actually the start of the mirroring line, and that's why I thought this footage was really excellent. Yes, it's long, but bear with me because it does show some interesting stuff. This mile is 4.84 miles from my location. Obviously, you've seen my camera was not very high. I'm guesstimating it to be approximately 5 feet. I know about how high that seawall is, and it's only about 3 feet. My camera's 2 feet, um, and it's also sitting down in about 8 inches of off down into the seawall. Now notice the birds that were flying away were starting to mirror out. In other words, this mirroring is starting to create an optical illusion of really a fake curve. That curve is not there, but this mirroring effect um, does cause objects to look like they're being pulled down, being cut off, but that's not actually the case. Also, look beyond um, this object, this little landmass here. This is some rocks that are sticking up that barely stick up out there, but I'm seeing them at 4.84 miles. Also, you see the birds where it's in the apparent horizon line. And also, look at this boat, and I'm going to actually take a snapshot of this boat. And I took a snapshot of it. The reason why I want to take a snapshot of it is because I want to compare it to another boat. Now, that was a pontoon boat, and here's this other boat coming in behind it. You can see him throwing up a wake, but look how the boat itself looks like it's cut off. And again, this is at, 4.84 miles, maybe 5 miles, because these islands do kind of um, angle away from me as you go more toward the south or southeast, as I should say. Um, you know, Looking southward and then panning to the east. But again, on a nice visible day, you can see these islands completely once you get away from that mirroring effect. But check this out. This is what's really cool too. You see these guys, and you say, "Well, where's their boat?" You don't even see their boat. Now, I'm sure that they're standing in a really low flats boat. Um, it's it might even be like a bass boat out on the water because I've seen some of these bass boats out there. They set so low to the water you don't even see them. But what's interesting is look at the size of these people, and then you say, well, where's their boat? Now, their boat is there, but this is something about moving water too. There's a deep channel just beyond those islands, and I do believe that boat is beyond the islands. And this can cause an issue because running water will rise higher than still water. You can lay a hose on the damn driveway and turn it on and see how the water that's being pushed away is going to be lower than the water coming out of that hose. It's weird. I just made a layman's description just to kind of give you an idea of what I'm talking about. But look at the size of this boat, and he's not much farther away than that 4.84 miles, but yet you can see the entire boat in the water with its wake. And what happens is where you start seeing the water blending into the sky. Um, Again, depending on the angle that I'm looking at, you're not going to actually see the mirroring. The mirroring is already there, but you're not going to see the mirroring of the objects beyond it. Like some of these signs, um, these channel markers, you're not going to see these things mirroring, which is really strange because, well, the mirroring is actually occurring beyond it. And it's occurring way beyond it because actually there is good visibility, but again, the mirroring is what confuses our eyes, gives us the illusion that all of this is I guess by scientific terms, being pulled up. But here's where I wanted to get to mainly in the video is this shrimp boat right here with its outriggers out. I start tracking this boat, um, and I track them for, you know, I want to say a half an hour, pretty much a half an hour before he gets to the point where he actually just starts distorting and blending into the background and getting hitting by this thin line of there's like a thin line of haze across the horizon, which when I zoom back and start zooming back in, you'll see this thin haze going all the way across the horizon. But in that haze, again, it's illumination. That haze is being illuminated, which is actually creating that mirroring effect. Or also what I want to say is when light bends upward off the surface, you've got to almost think of like a straight line, and then at the very end, depending on the visibility, how far that straight line goes out, the light starts bending upwards, which the surface or clouds above, when it gets to that same area or close to that same point, it bends downwards. So it's causing a pinch off of the horizon. That's why on certain days boats will vanish at a shorter distance than other days. Otherwise, Earth's curve would have to change on a daily, hourly. I mean, because I've been out there and seen different things within an hour or two, how objects change, and that's one reason why I took a picture of the Bayport bird rack, because at the end I want to show you the Bayport bird rack compared to another bird rack, and I also want to compare that pontoon boat to this boat when it gets really close to where I'm losing it, going into that hazy horizon. Now, what I talk about visibility limits too, but you also got to realize the visibility limits dictates the angular resolution and the quality of our um, of any object the farther and farther away it gets. Um, and here, as I zoom back, I mean, you can see these boats are way out there. These boats are way beyond the 4 mile mark. You can see the two boats. One's a small boat, and one's the bigger boat. Um, Now, the bigger boat will go around the smaller boat, and that's what I want to show too. And that's about where I want to kind of I want to take a picture so you can compare this pontoon boat that's, getting the bottom cut off at a much shorter distance, while this boat, you can see, I mean, right here, not only can you see the boat, but you can actually see its wake, depending on the quality that this thing gets put out under. Now, I changed my settings in my program um, to do like almost the best quality that I can, and it takes a lot longer for the video to process, but I think it's going to give me a lot better quality once it gets compressed by YouTube into their um, kind of crappy uh, program that they got. I mean, because I've seen some of my videos just look totally terrible compared to the original video that I have on my hard drive. Um, and this is, again, I think they've done this intentionally. And you see these other boats going by, and these boats that are going by are over 3 miles away, folks. Matter of fact, I'd easily say that they're 4 miles away. So when you compare the size of some of them boats, um, like the one boat that went by is probably half the size of this farther boat. That boat is probably about as big as that boat that this boat's pulling in front of right now. He's blocking it out. Yes, the boat that you can see with the riggers out is I mean, it is bigger than this boat that it's going to go past and go beyond. Um, but how far away are these boats? One might ask. Well, just out of my experience and videotaping these boats for as long as I have, knowing the distances. Now I just want to show you what it looks like with more light in there. Now I'm gonna pause this and change the light setting to the same thing that I had on the last one. Okay, again, contrast +5, brightness -50. Um, and you can see how if I would have left that light on there, how really these boats would have vanished long before. But you can see the reflection off of the small boat. You can see the reflection off the big boat, the light reflecting off of some shiny object that's on there, whether it be a piece of chrome or glass, I don't know. But again, here I zoom back. I show you that these boats are well over, 5 to 6 miles away. Um, Again, my camera height, these boats should be being cut off and below the curvature of, of the so-called Earth curve calculator. The bigger boat might be halfway cut off, and the smaller boat damn near all the way cut off. I'm not doing the calculations um, merely because of the fact that I'm showing you that this entire boat is in the water, although the water is starting to mirror the sky. And the sky, again, the air above it is hazy. So this is causing, you know, a hazing out effect, actually, or a man walking into a well lit room, or a foggy room where the weather conditions or this thin line of haze, this um, is causing us not to actually see the true water line beyond it. In other words, it's hiding it, it's blocking it. But with me keep changing the light, I mean, you kind of start seeing it more. And at a certain point here, again, I'm going to take a picture right here real quick, because that's the picture I want to compare to the pontoon boat. Now, you do got to realize that I'm looking more at the back of this boat than I am the side of it. So the pontoon boat, I'm looking more at the side of it. But you got to also think that, um, of the distances and the size difference of these boats. This pontoon boat's only half the size of this boat. So, how far again is this boat out? Um, I, I'm saying it's quite a ways out. Again, here you can see the reflection of um, this guy's engine, or again, some chrome objects that are out there on his boat. These boats are not being pulled up by some magical force of bending light or bending objects above the curvature of Earth. I think that is a false definition of um, what they would call a mirage. This is not a mirage of boats. These boats are literally on top of the water, and now the bigger boat is going to go beyond the smaller boat. Now, believe me, folks, that these boats look like they go right next to each other. You would not go right next to each other. Number one, he would have just netted the other boat. Um, he's probably at least 100 yards away, but it doesn't look like it. It looks like he's sideswiping this guy's boat and putting him in his net. But again, that's just the way our depth perception is perceiving it. Um, and here's something too that I constantly hear from the globe people: show us a working flat map of the world. Well, fortunately for us, almost every map that has ever been created, as far as you know a map, it's on a flat piece of paper, folks. They put maps on flat paper. Why? Because it's the best way to map out the Earth. Why? Because Earth is not a spinning ball of water in space, spinning at different speeds from the equator upward to the North Pole and southward to the South Pole. It just does not make sense. Because if that was so, you would have to have different amounts of gravity pulling the water down at different speeds, because at different speeds you're going to get different uh, centrifugal forces at every um, latitude line. It just does not make sense. And that's where people have to um, use their own common senses to understand how water is one of the best levels in the world. That's why they use it as sea level. And again, when I was making this video, I was really quiet. But, if I was to left the original audio on, you would hear me laughing as I see these other boats go by this boat. And I'm thinking to myself, well, how fast is this boat going? All right. When they got their outriggers out and their nets out, they're not going that fast. But this boat is continuing to move on and on and on. And again, I don't even know if he has his nets out or just his riggers out. He could just very well have his riggers out waiting for him to get to his spot to drop his nets. So again, I don't know exactly. Here I'm trying to focus it better. Again, I'm trying to get the best focus, the best resolution I can from it, from this camera, and I'm trying to use, the settings, the light settings, to block or give less light to, so we can actually see the horizon beyond this boat. And there is one. If you look very carefully, it's about even with the riggers, where he's got water that continues to go on beyond this. Um, so again, this may not be one of my um, best observations, but this type of observation shows how this mirroring that is occurring is beyond this boat. It's not in front of this boat. So again, this mirroring effect I've seen occur at 1.5 miles away from me 2 miles away, 3 miles away, 4 miles away, 5 miles away. I mean, you name it. I've seen it move at all different increments. And, you know, the farther that mirroring moves away, usually means the better visibility I've got for that particular day. Now, I've been out and I look at my phone and my phone says, well, there's 11-mile visibility today. Well, it depends. Um, because a lot of times, again, where are they getting um, these numbers, or how they even consider what the visibility limits are for a particular day? Check into that. You know, type it in. You know, how to determine visibility limits, and they usually do it at the airports, and they do it in a very short distance, believe it or not. Um, so that's why I think, you know, if they are in an area where they're not getting the same weather conditions that I'm getting, then visibility limits could change. But I have seen the visibility limits 11 miles out, because that's where the Cutter's Rock bird rack is. And I've caught it on these nice, clear, crisp days where water temperature, air temperature is approximately the same, and my visibility limit is 11 miles at 28 inches off the water. Like I say, you know, I was always hoping people would take like screenshots of my videos, get more familiar with my videos, and be able to use my videos to do some of their own research. Um, I am very honest, as far as usually trying to give you the best height of my camera. No, I don't take a tape measure out there. I'm just one guy, man. I mean, I carry sometimes two, three cameras with me. You know, I got a backpack with camera lenses and stuff, and all my batteries, and a chair, and you know, a drink, and I mean, I've got my hands full, and I'm only one guy. Um, Again, right here, you can kind of see where that mirroring starts. Um, Again, it's starting beyond this boat. That's why you don't see the boat mirroring um, in front of it. And you also see that it does leave a little bit of a wake that you can slightly pick up. But meanwhile, look at the boat beyond it. Again, I should have took a picture right here, but you start losing the resolution to its outriggers. See that, how that works? How the outriggers are starting to vanish? um, because we can't resolve them. They're too far. They're too small to resolve. It's like, I'm sure that there's a bird somewhere on that boat too, and we can't resolve it. Now think about those people that were standing there, um, and you couldn't see their boat. Now think about a person standing in that boat. I mean, you wouldn't be able to see him because he's so small, but you could see these people standing on a boat, but you couldn't see the boat at a much closer distance. Um, and this is where I say the angle of light comes into effect, and the amount of light hitting the water, reflecting off the water, all causes these mirroring effects, which the mirroring effects they call mirages. You know, you're seeing something that isn't there. No, I'm seeing something that's there because I've been tracking it for so long. Now, here's this boat, much bigger boat. Uh, it's at about, well, I don't know if it's much bigger, but that boat's at about 4 miles away. So again, you look at this other boat beyond it and you say, how far away is it? I should not see it, folks. That's my point. I should not see that boat. That boat should be well beyond the curvature of Earth and done gone over the curve and gone and hid from me by curvature. But yet there it is. And it's not being pulled up by some magical refraction of light, because I would have seen where that magical refraction of light started at. but we don't see it there. It's not there because it's not there. Now, um, you know, convergence is something too that, you know, I don't know why these globe people just don't understand it, but they don't. Now, on this next piece, I'm going to leave a little bit of the audio, but it is actually after the sunset. My battery died, and my SD card did not pick up the sun departure on my P1000. Full zoom. Now again, I took a screenshot right there when I said I'm at full zoom because I want to compare what this Bayport bird rack looked like when I got there, or when I took that first snap screenshot compared to what it looks like now. And this is where, you know, I try to tell people that, you know, these changes occur, and it can cause a compression, which again, this compression causes objects farther beyond to actually look more compressed too. And you know, I'll kind of show you, hopefully with a couple of boats here. This one isn't a really a good example because there is some kind of mirroring effect. But look at how you can see the wakes of the boat in the water, and how you can really see the water much better. You can see the horizon much better. But believe me, part of that black above that visible water is the horizon still. And that's what people don't understand. That mirroring effect is occurring way out there on the water. And that's why it's you know, doing this blending of the sky right into the water, this convergence. Again, here's another shot of Billy Steele's rack out there. It even got compressed a little bit compared to at the beginning of the video where I showed you it right beside this sign. Um, it's pretty interesting if you even compare where it's sitting in the water at, compared to, you know, in the very beginning too. I should have took a videotape or a snapshot of that too, but I didn't. I kind of want to leave some of this up to you, the viewer, to do your own research. But there was a very, very much compressed boat. How it's they're being more, um, you know, affected by this compression that is occurring. And again, I contribute this to a lot of the, um, you know, angle of the light that's hitting the water and reflecting upward, um, causing this apparent curve too, from left to right to center. I mean, from left to center to right of my field of view. Things do change, and it does give you this apparent curvature look. But again, here is the Hernando Beach rack, um, and it is also kind of compressed a little bit, but you can see the entire bird rack in the water, with water going well beyond it, the horizon going well beyond it. Again, I'm gonna cut this short after I show you the um, Bill Watts rack. Wow. almost couldn't think about it. The name. I haven't done any of these videos for a while, so kind of get forgetful, and I also forgot about some of the distances. But I think like Bill Watts is 3.8 miles away. Um, the Hernando Beach rack is 6 point something miles away. Um, the Billy Steele's rack is approximately 8 miles away, and that's from Pine Island. Um, that's why it's a little bit further than it is from Bayport. Um, now, I do have the exact distances somewhere. I've been cleaning my, I had to call it my pigsty office. It was pretty um, cluttered. I wouldn't say dirty, but more cluttered than anything. And then here again is um, the Bill Watts rack. And this again is at 3.8 something miles. Obviously sitting flat dab in the water. Again, I did look for um, the Cutter's Rock rack, but I'm not sure if this sign was in my way, or if I seen it and just didn't see it. Again, it was kind of getting toward the end of the night, and I was wanting to get out of there. Um, when you're out there just kind of by yourself, yeah, it kind of gets a little bit of a bore to it. So excuse me. So I mean, right there, um, I'm kind of looking at the where I usually sit and where I'm at now, and I thought, wow, it very well could have been right behind that sign. And you've seen how much of that sign, how much of the horizon it blocked out. But even here, look at these boats. They're way out there, and I'm still seeing their wake. And I mean, that's a pretty good sized wake. When on other days, again, when there's heavy mirroring, I don't see any wake of these boats. And a lot of times, like I say, these boats are being cut off. And I believe also that there is, I mean, I do have proof of magnification, and I want to show that too. But let me get to these pictures and just give you a quick comparison, and then I'll end the video. Okay, the bird rack are the same. This is Bayport entrance rack. The one on the left was taken before sun departure. The one on the right after sun departure. Big difference. What's the difference? I'll leave that up to you. All right, here's another one where this boat, you can see the mirroring just below it with a little gap in between the mirroring. The one on the right, you can see this boat is a hell of a lot farther out than this pontoon boat, but yet it's not being cut off or hidden. All right, now this was a comparison with these two people that you can't see their boat. This was made way toward the south, and then this was off more toward the west, the picture on the right. Now place those two people in that boat. Um, Here's the other comparison I went back and I made with the Billy Steele's rack. The one on the left was before sun departure. The one on the right was after sun departure. You see the difference where one's compressed and one's kind of stretched. And then my last one was just comparing the person that was on this boat compared to those people that were beyond the Hernando Beach channel. Again, I leave a lot of this up to you to decide. Thanks for watching.